Hello everyone. Today in this video we are going to understand evolution of integration by using Laplace transform. So let us understand with the first example. Integration 0 to infinity e raised to minus 2t into t into cos t into dt. So the solution is, we know that Laplace transform of cos t is equal to s upon s square plus 1.
Now, if you look in the example, there is a t multiplied with the cos t. So we will use multiplication by t property. So by using multiplication by t property, Laplace transform of t cos t will be equal to minus 1 into d ds of s upon s square plus 1. Now we will take derivative of it. It will be minus 1 into s square plus 1. So derivative of s will be 1. So we will not write it. So it will be, now s will be as it is, and derivative of s square plus 1 will be 2s. And it will be at denominator, it will be s square plus 1 bracket square. Now we will solve it further. It will be minus 1 s square plus 1 minus 2 s square upon s square plus 1 bracket square. Now minus sign will be we will solve it. So minus 1 will be as it is. It will be minus s square plus 1 upon s square plus 1 bracket square. So minus sign will be multiplied inside. It will be s square minus 1 upon s square plus 1 bracket square. So we got the Laplace transform of t cos t. Now if you see in the example, we have integration varies from 0 to infinity e raised to minus 2t into t cos t dt. So we will use definition of Laplace transform for this. So by using definition of Laplace transform, integration varies from 0 to infinity e raised to minus st f of t dt is equal to f of s. So integration varies from 0 to infinity e raised to minus st. F of t is nothing but t cos t, and f of s is nothing but s square minus 1 upon s square plus 1 bracket square. Now we will put value of s is equal to 2, because we in the equation we have e raised to minus 2t. So by putting value of s is equal to 2, it will be integration varies from 0 to infinity e raised to minus 2t t cos t will be equal to value of 2 will be 2 square, means it will be 4 minus 1 upon, by putting value of 2, it will be 4 plus 1 bracket square, which will be equal to 3 upon 25. So therefore the integration 0 to infinity e raised to minus 2t t cos t is equal to 3 upon 25.
Now let's take a second example of Laplace transform. We all know about the Laplace transform of sine of at. It is nothing but the a upon a square plus a square. Let's put here the a equals to the 1. Then Laplace transform of sine of t. Laplace transform of sine of t is equals to the 1 upon a square plus 1. We are also familiar with the sine of hyperbolic t. It is equals to the e raised to t minus e raised to minus t divided by the 2. So by further solving this, By further solving this, we get the equation like e raised to t minus e raised to minus t divided by 2 into sine of t. Now put sine of t in the equation in the bracket e raised to t sine of t minus e raised to minus t sine of t divided by 2. By using the linearity property, we can solve it like by taking 1 by 2 common from the Laplace. Then the equation becomes e raised to t sine of t. By taking separate Laplace of this term, then it becomes 1 by 2 e raised to minus t sine of t.
Shifting property. So that's it.
Now further we can solve this example by using definition of Laplace transform. By using definition of Laplace transform. So integration varies from 0 to infinity e raised to minus st f of t dt equals to, our original equation is integration varies from 0 to infinity e raised to minus 2t sin ht sin t dt. So while comparing both the equation, we can replace s equals to 2 in our f of s. So our f of s is 1 by 2 in bracket 1 upon s minus 1 bracket square plus 1 minus 1 upon s plus 1 bracket square plus 1. So here we can replace s equals to 2 in this in f of s. So 1 upon 2 minus 1 bracket square plus 1 minus 2 plus 1 bracket square plus 1. So after solving this equation, we will get the answer 1 by 2 4 1 10. So final answer is 2 by 10 is the final solution of this given equation. From this example, we can conclude that when the integration varies from 0 to infinity with some function, that time it difficult to solve. That time we use the evolution of integration by using Laplace transform.